Atoms are the structure of life, but scientists did not always understand the basic structure of an atom, let alone their existence. Early theories of the structure of matter were not based upon experiments. As scientists began to study the relationship between several physical phenomena, such as electricity and magnetism, they began to develop different models about atomic structure. Let's go back and discover the atom. Boop! Zoom!
The year is 460 BC, and this is Democritus. He believed that there was no difference in atoms but size and shape.
By convention bitter, by convention sweet, but in reality atoms and void.
Aristotle then took Democritus's theory and compared it to the alphabet. Similar to how different combinations of letters make different words, different combinations of atoms make different elements.
He was a lovely man, wasn't he? Now let us check in with Antoine Lavoisier to see how combustion played a role in his discovery of elements. Zoom!
Some may ask, what makes me so special? Why are my discoveries considered the turning point of modern chemistry? Before my famous experiment, scientists would heat metals in air, and these metals would become calces. When metal was heated in air, they gained mass. Scientists were baffled as to where this added mass came from, so I took matters into my own hands and heated metals in sealed chambers. I found that the mass gained by the metals was equal to the mass lost by the air. Thus, no new mass was created, but mass was transformed.
Wow, thank you so much.
Lavoisier found that a metal oxide weighs more than the metal because it contains the added mass of oxygen. Thus, the law of conservation of mass was born out of Lavoisier's findings. Let's go visit Joseph Proust. Zoom!
Hello, my name is Joseph Proust. Matter is neither created nor destroyed in a chemical reaction, and my law states that a chemical compound always contains exactly the same proportion of elements by mass.
Thank you so much, Proust, for your important contributions to the field of science. John Dalton presumed that if elements were made of tiny indivisible particles, then molecules of a particular compound would always be composed of equal numbers of each type of element. Thus, each element in a given compound would account for a consistent percentage of that compound's mass. Zoom!
Each element is composed of tiny particles called atoms. All atoms of a given element are identical, and all atoms of different elements are different. Atoms are not created or destroyed in chemical reactions. They are dissociated, combined, or recombined. Compounds are formed when atoms of different elements combine with one another. A given compound always contains the same relative numbers and types of atoms.
Thank you, John Dalton. Zoom! Whoa! It seems that we are in the time period of J.J. Thomson. In 1897, J.J. Thomson discovered the electron. Originally, Thomson believed that the hydrogen atom must be made up of more than 2,000 electrons. According to Thomson, this is how the mass must have been accounted for.
In 1904, I proposed the plum pudding model of an atom. In my wonderful model, the atom is composed of electrons and surrounded by a large positive charge to balance the negative charges of the electrons.
Hi, I'm Kaylee Showalter. Here is a modern version of Thomson's model. It's called a plum pudding model because the electrons' negative charges resemble plums, in this case, blueberries. Delicious.
Zoom!
Ernest Rutherford tested J.J. Thomson's hypothesis by creating his own gold foil experiment. Let's go ask Rutherford about his experiment right now.
That is correct. My reasoning was that if Thomson's model was correct, then the mass of the atom would be equally distributed throughout the atom. When I tested my gold foil experiment, I shot positively charged alpha particles through a thin film of gold atoms. Most alpha particles went through the film, but to my surprise, some alpha particles rebounded backwards, which is inconsistent with Thomson's model. I reasoned that the only way these alpha particles could rebound backwards is that if the majority of the mass is concentrated within the nucleus.
Zoom! Who are you? Where are we?
I'm Niels Bohr, and the year is 1915. I have just proposed my model, the Bohr model, for the atom. My model shows that electrons and atoms are in orbits with different energies surrounding the nucleus. These different orbits of energy are called energy shells.
Wow, thank you. It is great to meet the man who developed the model of the atom that we use today to diagram.
Zoom!
Back to the present. Thank you so much for watching, and maybe one day you can contribute to the wonderful field of science.